about using the wave equation. So we have two equations here to use for our wave equations. Oops, that's an F. We have C equals lambda times F and E equals H times F. So the first thing you need to do is know what all those symbols mean. So let's start with the weirdest one first. Lambda is this kind of funny little letter here. It's a Greek letter, and it stands for wavelength. Remember, wavelength is the distance from crest to crest on a wave, and that can be measured in any kind of distance units, and we would use meters most of the time, but sometimes we would use centimeters or nanometers, something like that. Okay, some others you would need to know. F stands for frequency. That one might be a little bit easier to remember. That's how many cycles there are per second, and that's measured in hertz, which is basically 1 over a second. So again, how many cycles per second. E is also one that's pretty easy to remember. That's energy, and that gets measured in joules. We also have two constants. So these are pretty important. C is the speed of light, and with these constants, you always plug the same thing in for C, so the problem's probably not going to give it to you. So you will need to remember this number. It's 3.0, or write it down somewhere, 3.0 times 10 to the 8th meters per second. So that's not going to be given to you, okay? The other constant that you will see in these problems is H, and that's called Planck's constant. It's named after the scientist that developed it. And again, this is not going to be given to you in the problem, but you need to have it in your notes so you know just to plug it in. And this number is 6.63 times 10 to the negative 34th joule seconds. Okay, so now we're going to look at a practice problem, and there will be another video that shows some problems in the packet, but just watch this one and follow along. So it says, calculate the energy of a photon of yellow light with a wavelength of 575 nanometers. Now, with nanometers, this tells me it's a wavelength, okay, so that's going to be that funny symbol there, but it has to be in meters. So I'm going to have to convert that, and if you do not remember your metric conversions, there is a metric conversion resource video for you, and so you can go back and watch that. But nanometers, there's 1 times 10 to the 9th nanometer for every meter. Okay, so when I divide that out, I get 5.75 times 10 to the negative 7th meters. Okay, and this also reminds me that we're going to be using scientific notation in this unit. So there's also a resource video for scientific notation if this notation right here is confusing to you. Okay, but I'm going to go ahead and move on and show you how to use the equation. So we want to calculate the energy of a photon. So what I have is 5.75 times 10 to the negative 7th meters, and that's my wavelength. And what I'm looking for is energy. Okay, so I need to pick my equations out. So if I look at my two equations that I just went over with you, I have these two equations, and I have this. Okay, so we could use that equation, but it doesn't have what I'm looking for over here. But this is a little tricky because I have F in both of them. So I can solve for my frequency first, and then I can use that frequency in the next equation. Okay, so I'm going to use actually both of these, this equation first, that equation second. Okay, and I'm going to show you a couple ways to solve each of these equations. So the first one I'm going to solve using algebra. Okay, so again, I had 5.75 times 10 to the negative 7th meters as my wavelength, and on this first equation I'm trying to find frequency, and it has C in it, and if you recall, C was our speed of light, and it's always the same number, 3.0 times 10 to the 8th meters per second. Okay, so what I'm going to do now is plug all these things in. So I know my C, and then I have my wavelength, 5.75 times 10 to the negative 7th, and then I'm looking for F. So to get F by itself, I want to divide on both sides by 5.75 times 10 to the negative 7th. Okay, it's going to cancel over here and leave F all by itself. And then over here, this is going to be our math problem that we're going to have to put into the calculator, and I'm going to show you how to do that. And our meters are going to cancel. Okay, so just to show you how to put it in the calculator, because it's a little tricky with scientific notation, I put my number in first, 3, and then this times 10, instead of putting times 10, I'm going to put second, and then the EE button, which has an x to the negative 1 on it as well. So you want to find that on your calculator. Okay, then I'm going to push the 8. Okay, then I push what I'm doing, and here I'm dividing. So I'm going to push divided by, and then my second number, 5.75, and then second, EE to the negative 7. And then I push my equal sign, and that's going to give me my answer. In this case, my answer will be 5.22 times 10 to the 14th, and I'm measuring in hertz. So that is frequency, and that's my answer. Using the second equation, E equals H times F. My F I just found on the last problem. That was 5.22 times 10 to the 14th hertz. My H is my constant, 6.63 times 10 to the negative 34 joule seconds. And I'm looking for E. So my first strategy is going to be to use algebra. I have E equals HF, so I'm going to plug in 6.63 times 10 to the negative 34th joule seconds times 5.22 times 10 to the 14th hertz. The hertz and seconds cancel. Okay, and I'm going to have joules. And again, I'm going to show you in the calculator what you would push. You're going to do 6.63 second EE negative 34, and then you're going to put what you're doing. This time we're multiplying, so I'm going to push the times button. 5.22 second EE 14. Then we push our equals button. That's going to give us our answer, which in this case, my energy is going to be 3.46 times 10 to the negative 19th joules. And that's my answer.